Followed every little thing. We too big to turn upside down.
Hang out there.
We will be starting in a minute or two. We'll wait for the last couple stragglers that inevitably come in right after the time. All right, let's go ahead and get started. My name's DJ Lincoln. Roger Averbeck is sitting around the corner there. And this is a presentation about the aurora borealis, both the science side and the photography side of it. If you wouldn't mind silencing your phones, we've had some requests to do that. Keeps the distractions down, general theater politeness. Thank you. Who are we? Well, my name's DJ. I've been a science educator around here for about 10 years, and member of the astronomy club here, sometimes the only member, for decades at this point. That involves a lot of setting up a bunch of equipment out in cold, beautiful parts of the county and seeing pretty much nothing. But that's okay, because on May 10th, I met up with Roger outside the OK Theater. We said, yeah, we both think there might be aurora tonight. Let's go out and see it just in case. I went out expecting nothing. Roger went out expecting not much. Roger brought his camera equipment. He's a professional photographer, but as he was often pointing out, an amateur at astrophotography. So we were deciding on settings for cameras there. Mostly I was staring back going ooh and ah. Occasionally I'd say something physics related, but a lot of it was me watching Roger go through this discovery process of what is it like to photograph the aurora borealis. The structure of this presentation will be, I'll give about 20 minutes of talk about the science behind it. Part of that will be a bit of a Q&A. Then I'll hand it over to Roger for a section on the photography. There will be another Q&A section after that. And ask questions in the middle of it. Please interrupt. Please heckle if you have to interrupt. Thank you. This works way better if people are a little more active and engaged. It lets me know the parts that aren't clicking in the presentation, and it keeps you guys engaged, especially kid questions. Absolutely raise your hand for those. So, what we're going to talk about is the aurora on May 10th. And as you may have heard by now, they were pretty weird and unusual. But in order to know what usual is, well, what's normal? This is the aurora forecast for tomorrow night. Kind of green. Maybe you see auroras south of that. Yes?
Hold the microphone closer to your mouth.
Absolutely. Okay. This is tomorrow night's aurora forecast. It's not much. Okay? What did this same chart look like on May 10th? That. Okay, this is weird. This is really cool. What made this happen? As a tangent, I want to talk about something else that happened on May 10th. But this wasn't May 10th, 2024. This was May 10th, 1962. May 10th, 1962. An incredible event happened. The first printing of the Incredible Hulk. If you don't know who this marvel of Marvel is, the Hulk, Bruce Banner, was hit by radiation. He gets excited. When he gets excited, he gets angry. And then to calm down, he throws things. Remember this four-step process? We'll come back to it. Okay, back to our astronomy land. For the forecast of May 10th, this went all the way down below our latitude. This under-forecasted a bit. The actual event of it had the visible line going well down through southern Texas. There were aurora visible in southern Florida. That is a once-in-a-century thing. Seeing cool aurora here, we get that every couple of decades, but having more than this was a lot. This is an image from an orbiting satellite and NOAA of that night. Of course, it's an image of the U.S. at night. There's all the city dots. And the city puts out quite a bit of light. Well, scatter all that light into the upper atmosphere and have it being generated up there. It was bright. How this happened? remember our Hulk stories. To make aurora borealis, first, Earth's magnetic field is hit by radiation, then the magnetic field gets excited, then the atmosphere gets angry, and then the atmosphere throws things to calm down. Let's go step by step. First, we got to hit the Earth's magnetic field with radiation, which comes from the sun. This is an image of the sun in a normal is a bit of a misnomer because this is actually a very quiet phase for the sun's surface. This is about 7 years ago, May 10th, 2018, the quiet phase of the sun's solar cycle. It's an 11-year cycle. 11 years from there will be another quiet phase. 11 years from now will be another very active phase. Here you can see a couple of sunspots, and this is not a visible image of the sun. It is called a magnetogram, which measures the magnetic field strength of different effects on the sun. This is a magnetogram from just before May 10th. There's a lot more dots. Those dots are sunspots. Those sunspots are irregularities in the convection of the surface of the sun, very associated with magnetic fields. Here's a picture that Roger took, and you can see the sunspot coming out in that. So these magnetic field differences were strong enough to be causing visible light differences in the convection of the sun. Not unusual, but this was a pretty big cluster. When you have a big cluster of sunspots that has the magnetic field tossing around there, sometimes it tosses stuff out. That is called a coronal mass ejection. And this image from 1997 is the sun putting a coronal mass ejection straight out toward Earth. So this isn't the sun doing this, it's the sun doing this towards us. Towards us means a lot of particles. Okay, now we got to get our magnetic field excited from those particles. And frankly, this is hard. I looked at a couple ways to explain it. We can talk later if you want. Here is the best hand wave I can give. There's a whole mission to Jupiter right now called the Juno Space Program, Juno Space Probe, that's studying this intensely in Jupiter. When the Earth's magnetic field is hit by particles from the sun, it gets bent. And if you bend it enough, then the backsides of the magnetic field touch, and that completes an analog of a current. What happens then is the charged particles that were in this magnetic field from the sun fall back towards Earth. You can get them in the daytime, you tend to see them at night because it's dark. Okay, now we'll get into some more chemistry with our atmosphere getting angry. These are emission lines of various elements. Who knows what a Merck vapor is, or a sodium vapor lamp? They're on every barn around here. They're pretty big and bright. If you took all of these colors down here and you mixed them all together, there is a mercury vapor lamp. Neon lights, all the bright signs around in, not so many in Enterprise, but neon lights is these added together. You can make an oxygen light or an argon light, but people don't tend to do that. Some things to remember about this chart that we'll come back to is that these are just for single elements. If you get something complex like DNA and look at its emission spectrum, it's way more lines. We tend to have a lot of nitrogen in the atmosphere, which this is monatomic. Diatomic nitrogen we've got a lot more of that. And when a element is excited and emits its electron to bring its energy level down, not all emissions happen at the same rate. For oxygen, for example, the greens will happen pretty quickly. But energy can be stuck in the red level of that oxygen atom for a long time before it will finally fall down. Lastly, this is a thing more about the atmosphere than about this chart, is that our atmosphere has light stuff on top and heavy stuff on the bottom. Just like if you had a box of sand and ball bearings and you shook it, the ball bearings would go to the bottom. Atmosphere is the sand, nitrogen, CO2, bigger stuff. Those are the ball bearings that fall down lower into the atmosphere. Here is just the oxygen spectrum. Notice it has some green and it has some red. Now that we've gotten our atoms excited, let's calm them down by having them throw photons at us. This is a chart we'll be sitting on a little while. This is a schematic of where different colors in the aurora come from in the atmosphere. Let's talk about them. The top one, red light. At the top of the atmosphere, because it's high up, this is about twice the elevation of the International Space Station, it's mostly single light atoms. Single oxygen, for example. And that oxygen can fly around a long time before it will ever run into anything else, which means it's mostly undisturbed. And that gives plenty of time for the longer emissions to happen. Therefore, we get red light from higher up in our atmospheric column in the aurora. Similarly, there is oxygen this is close to the elevation of the International Space Station. Green light emits quicker, which means that the red light doesn't have time to sit in the oxygen levels long enough before it will emit out. So the only thing we see from these lower elevation oxygen atoms is the green light. As you get down lower in the atmosphere, you get that big mess of heavier particles. Not only does it take a kind of an exceptional bit of energy to get down through the upper bits of the atmosphere to actually excite the lower levels of it, so you only tend to see these during extreme aurora. But the things that it hits down there, it might hit oxygen. There's plenty of oxygen down here, but there's also plenty of nitrogen and CO2 and argon gas and whatever you burped up for breakfast. So lower atmosphere is a bit more of a mess, which means a wider spectrum of different colors. Lots of colors because there's more stuff lower in the atmosphere. So I'm going to give a brief set for, if you have any questions that you're dying to ask and you haven't raised your hand, let's ask them now. After this, we're going to transition over to Roger, who's going to show you actual pictures of this stuff. Question?
How do we join your astronomy club? Because I'm dying. I'm so lonely. I just stand out there by myself and I'm like, what is that?
It's way better in company. I wouldn't have gone out if Roger hadn't tapped me on the shoulder and said, let's go out tonight. Okay. There's a Facebook group. There isn't an email contact thread, but keep me your name and numbers, and we'll be one of the folks I reach out to when there's something going on. I head out, and likewise, reach out to me if you're heading out, or you've got house guests that want to see the dark sky around here.
I don't know if I'm going to make this make sense, but I'm going to try. So do we have colors in the sky more frequently than we see, and that we can't see them because of their density and their weight?
Yes, that makes sense, and you're on the correct track on that. Roger will talk a little more about it. He's got a photo comparison. In short, it takes... our eyes are adapted to work in the daylight. We look at large animals trying to eat us. We look at our friends and family, and we look at berries on trees to hunt and eat. That's what our eyes are good for. None of those take a really strong dark vision set. Seeing really faint colors at night, seeing really dim objects at night, our eyes are way less good at that. So to see more colors, we have telescopes and cameras. And there's various ways to get more energy on our eyes. So that's either more brightness or more color. But the two big ways are have bigger eyes or trick your brain into having a longer exposure time. We can't do that, and if anyone wants to give me a superpower, I would like to be able to change the exposure time of my eyes, please. Yes, because cameras were using a longer exposure time.
We were looking at your map at the beginning of how far down it was. On May 10th, we were in Ireland.
Oh,
And we heard all this was going on here. So was it daytime there? Did it not look far south there? So how does that look when you go around the world?
that band of aurora activity, that is not a where are the particles hitting Earth map. That is a where can we see aurora map. So it tends to really faint out during the daylight time because it's too bright out to see the aurora then. So that it would have been visible in Ireland. I know it was visible in the UK, like England and Wales. I believe that the timing of it specifically may have had some minutes of time where we didn't see much, and then the sky exploded for 15 or 20 minutes at a time. And if it happened to be daylight out at that time period, we wouldn't have seen that. Or cloudy.
There's an 8-hour time difference.
Um,
in Ireland.
Here in Ireland is 8 hours. Well, 11 o'clock at night is when the sky exploded here, so that would be 7 in the morning.
So on that night, I just happened to go out towards 11:30, like, well, I'll try one more time, right? And of course, I was just beside myself at what I saw. And I took pictures in all directions, and I have pictures with every color band of light in them. So my question is, when it wasn't like, well, I don't know if it was dark red, but it was bright pink. Is it possible that that light was the red band that came from twice as high as the space station coming all the way down here?
Almost certainly. That red band might have been higher up in the sky to you, but it could also be brighter in the far distance, far above a part of the Earth, maybe even over the curve of the Earth. So
So I have a second question. We had a corona that looked like it was right over Chief Joseph Mountain. And then I see pictures from a friend who lives in Gardner, Montana, north of Yellowstone. She has the same thing. I've got pictures from people in Tri-Cities, the same thing. So is that because the gases that created the colors were so extremely high in the atmosphere that they could be seen by people at a very broad distance?
yes, and we'll hand over to Roger to take some pictures, to show some pictures of this. But as I have the floor space open, as Roger's coming up here, I'll answer that question in a slightly different way. And I'll lose the mic on this, so I will. Thank you, live audience. When you're looking at those aurora effects, and you see, oh, there's this bright corona over Mount Joseph. Well, that corona is you looking at something really far away. That's hundreds of miles up
Thank you all for coming. DJ did a brief introduction for us, but I'll share a few more things about me. I've been doing photography and even tried astrophotography in the late 70s, but I'm definitely not a professional in it. That May 10th experience was the first time I was ever attempted to capture any images of aurora. I had seen him back in that same time on a canoe trip in the Boundary Waters and into Quetico Park in southern Ontario. And really nice display, lots of movement patterns, green colors and stuff, but I've never been able to try to photograph them. And so a few more things about this experience. Like DJ said, I just ran into him outside the OK Theater by coincidence and said, I'm pretty sure there's going to be some aurora tonight, so would you like to go out somewhere? I started seeing information on social media about the aurora and the sunspot activity the day before, Thursday, May 9th. And it caused me to run outside in my driveway and take that photograph of the solar disk that shows the sunspots. Of course, I was using a proper solar filter on the camera, and I was also had the camera in live view because you do not want to look through your telephoto lens at the sun ever. No way. And and you should have even what you know as eclipse glasses if you're going to mess around with that stuff. But I knew that solar sunspot, I think it was called 3664 was the number, and each time the sun rotates, and then the same sunspot is still there, but then they give it a new number. And I don't know why exactly, but that's the protocol. So I started sending out information on Facebook myself later on Thursday, giving people a heads up about it. And but I really didn't know what to expect. So DJ and I went out on Swamp Creek Hill. It's about 9 miles north of Enterprise, straight out Highway 3 towards Lewiston, and then take a right up Swamp Creek Road, and it's just a short ways up there, quarter mile or something to the top of the hill. And it was really a beautiful evening. We got up there just before 10 o'clock. We ended up staying until about 2:30 in the morning. But when we arrived, there was clear skies, no wind. It was about 54 degrees, and it was a nice evening. There were coyotes howling. We heard barn owls screaming. A chorus of frogs. Something else which I couldn't identify. It may have been a long-billed curlew bird call. That's this according to Kendrick Boholt, my friend. But I didn't do an audio recording, so I can't really. But so anything you see in these photos are not clouds. There were no clouds that night. So it was kind of not only the solar storm of the century, it was a perfect storm of conditions. Because I've known about aurora hitting Wallowa County many times previously over the years, and it was always cloudy. And so finally we got lucky with this one.
Why does it look like fog?
Well, you were just seeing, with human eyes, you were just seeing a lot of diffuse aurora here at mid-latitudes, and it wasn't colorful at times, grays and whites. We definitely saw that. I went back out there Saturday night, and it just looked like this bright glow coming from north of us that I knew was not the metropolis of Flora. And so it was the aurora, but there were no colors hardly. And so that was Saturday night, May 11th. Definitely auspicious that the Hulk was introduced on May 10th, 1962, which is actually 62 years previous to our experience here, to the day. I don't know. Yeah, that's very convenient. So this is an image taken about when we first got out there. I don't have the time noted, but and I actually reduced the colors in this to a bit. So can you see some gray and some bands in there? Yeah. There is a little bit of pink up in the area on the left side, but so how many of you actually saw the aurora that night, May 10th? Okay.
Only the gray one.
Only gray. That was my next question. How many of you saw color? All right. And did any of you try to photograph the aurora? And what did you capture? Some colors? Nothing? Not much? Okay. Yeah. Well, I'm going to attempt, I'm not going to spend this much time on all the slides, but there's only about 14 slides, so, and I think I'm doing okay on time still. Yeah, in fact, DJ finished ahead of schedule. So, human eyes have evolved over the centuries to see color in bright light very well, unless, of course, someone's colorblind. That's different. But they did not evolve, our eyes did not evolve to see colors in dim light. As an example, when you go outside at night in a bright moon and you're standing in your backyard and you know there's dandelions there, are you seeing yellow or not really? They're kind of white or gray. Okay. To dive a little deeper into this, the human eyes have cells in the retina, which is in the back of our eye, that are called cones and rods. And those have slightly different functions. And I'm not a doctor, I'm not an optometrist, but so the cones are the cells that are evolved to see color very well in bright light conditions. And the rods kick in under dim light, and they are better to see contrast, and but not so much with color. Now, why that is, I don't know. There's also a great deal of variation in humans. You know, one people see color really well, and others not so much. I talked to a couple friends of mine recently who they both went outside in their backyard in Enterprise, and the woman was like, meh, I just see some gray stuff. I'm going back to bed. Her partner was totally amazed. He could see 4 or 5 different colors and was really excited about it. And they were experiencing the same thing. Other things that, of course, affect us are age, the colors, and our eyes deteriorate as we age, and then there's just the human variation. So I appreciate your interest in that. Now, on to the next thing is whether or not, why is it, I hope you can see some color there, why is it that the cameras can capture things so much better? Well, yeah, I'm seeing greens and yellows and some pink, maybe a little purple there. That was a 10-second exposure. I don't know if you really care too much about the image data, but I can explain that or talk more about it after the show. One thing, that's the camera that I use. That's a Nikon D850. It's a 14 to 24 millimeter wide-angle lens. And I always try to focus on infinity, not using the camera's autofocus, because it won't know what to do looking at night sky. And to help with that, I use a little bit of blue tape. And there's focus on infinity, tape it in place so you don't have to mess with that. Eliminate one of the variables. So, back on track here. I don't do much enhancement of images afterwards. I might change the contrast a little bit, overall brighten the photograph a little bit. These look much better on a computer screen than they do on this big screen during daylight. We should have had this presentation at night when it's not so bright out, because we're losing a lot of the detail. But camera sensors are designed to gather a lot more light. They can stay open for a much longer time, 10 seconds. I did also, you'll see some longer exposures, 20 seconds, or 15 or 30 seconds. And then, as compared to the human eyes, where cameras have an aperture, which is the size of the hole in the lens, and humans have a pupil, and that, when it's wide open, it's kind of like a camera aperture is wide open. But there is a hack, DJ, that you can use to kick in your cones when you're out viewing stars and the aurora at night. We're usually using our rods. But if you take a bright flashlight and shine it near your face, your eyes respond and your cones kick in, and all of a sudden you might see more color in the aurora than temporarily, until your eyes adapt and the rods take over again. So that's really interesting. That's a hack that you can do to fool your eyes into thinking it's brighter than it is. And of course, there's a huge variation in brightness of the aurora itself. And so when it's dimmer and more diffuse, especially at mid-latitudes like we are, then often there's, for times, DJ and I could only see some grays and not the colors. But we definitely experienced, we could see green, we could see some reds and purples, all with the naked eye while we were out there. So this was something I attempted to do. That's looking west, obviously, with the setting crescent moon. It was only a 10% crescent. And if you've tried to take a photograph of the moon, it's easy to make the mistake of overexposing it. Often with your smartphone or whatever, it just kind of looks like this big, bright blob. And so to accommodate that, I changed the aperture, f22 as it's called, to a very small hole. And then as a result of that, I had to increase the exposure time. The shutter was open for 30 seconds. And that creates that nice star-looking effect for the moon. It turns out that that was a bit of a mistake on my part, because when I decided to turn my camera away from the moon and start trying to do more aurora photos, I didn't change the settings. And so that's a lesson learned. But that was taken at about 10, a little after 10. Another thing about the aurora that we experienced was that there was a lot of shifting colors, as well as the brightness, as well as just actual movement. Did anyone else able to experience that? You saw the movement? Yeah. That was really cool. And that is a deficiency of trying to take still photos. You lose all that motion. Also, having a 30-second exposure, of course, any of that is completely gone. There is something that I attempted to do with a video camera. I had that set up and running, and it was totally black. Couldn't see anything. And when I looked at the video later, and except I did capture the audio of DJ going, "Wow, wow, wow," and so I mean I've been out with him a few times, and I've never heard him say "wow" 3 times in 10 seconds, and that was amazing. Do y'all have any questions as we go? We encourage the discussion.
Why the video didn't work, like to use 7 different frame speeds?
Yes. I didn't experiment with that. There's no filter on the video camera, and I just let it run for several minutes. I think a lot of the videos that you see, if you go on YouTube, of videos of Northern Lights, what they actually are is time-lapse photography. They're a series of still photos shown, and it's actually much faster than what you would actually capture with a camera. Now, and I've been trying to do some research on if I'm going to do this again when the big storm hits, or if I do my bucket list trip to Iceland or Alaska somewhere in winter only. I'll try the time lapse, but video didn't work at all. Any other questions? Yes.
I'm personally a big fan of the fact that you put your camera setting specs on these because I'm kind of a hobby, not photographer, but just sensor, imagery sensor person. I like doing drone mapping and learning about remote sensing, and so learning about the wide variety of different types of sensors there are. Like DJ showed that magneto, what was it again?
It was called a magnetograph.
Yeah, the magnetograph. Yeah, and the way that different sensors pick up different different bands on the spectral spectrum is really interesting to me. So,
Well, thank you for that comment. I didn't hear a question, but no, that's great. And it's pretty easy to do now, with modern digital cameras, because that data is recorded with each image, and after the fact, I could just go back and look it up and then include it in the PowerPoint. In the old days, the photographer had to write down all the settings and then try to make sure it was the right setting for the image that they were looking at. But again, this is the first time I ever tried to do photographs of aurora borealis. I took 192 photos that night, and on the first round of editing, I cut it back to about 42 images. And a lot of them were black and blurry and whatever, or there were multiple images of the same thing. And then to get to this presentation, now there's only 14. So I hope it's the best. So see how it's different. You've still got the setting crescent moon. And this was taken at 10:50 p.m., but it won't set until 12:20 after midnight. And we got some nice colors in there and some bands. This is the corona display that was asked about in DJ's presentation. So we're looking at right in the center, that's zenith, which is the exact opposite point in the sky of where the sun is. So it's directly overhead. I had to point the camera straight up. And I'm pretty sure that the orientation on this would be that the bottom of the photograph would be to the south. But the aurora that we experienced both visually and with cameras, it was about 270 degrees on the horizon, and then it went completely overhead and down towards the south a bit, which just blew me away. That was way more than I expected. Like I said, when I've seen them in the Midwest, northern Minnesota, some green stuff a little bit above the northern horizon, and that was really cool, I thought. And to see this, It was truly, maybe, hopefully not, once in a lifetime. Just a few more images. I don't even know which way that was pointed. DJ might be able to pick out constellations, but they are all in chronological order. You can see the time is getting later, and I was still doing the 30-second exposures, and a fairly high f-stop. And really, it is a mistake, and I'm humble and admit to that, because usually in astrophotography, you want a wide-open lens. And so what would you have captured if it had been wide open? F 3.5 or 5 or so, depending on what lens you use. We might have gotten more contrast, more precise image rather than the kind of a blended colors there, but
As a point of reflection
Sure.
on this image, the green is about 100 miles closer to you than the red. So when you're seeing these auroras, you are seeing massive shapes in the sky. And when they move and shimmer, you're watching a shape or a shadow or an effect that's moving way faster than probably anything else you've seen.
thank you for that, DJ.
So was this color, is this color lighter than what you actually saw?
Lighter? You mean brighter or
Taylor?
paler? I would say the colors in the photograph are brighter and more intense than what we are seeing. Because we're at the mercy of our human eyes, and mine aren't as good as they used to be. And maybe DJ was seeing a more intense display because he's about half my age or less. Yeah, I appreciate that. Another interesting thing, I've learned so much since this event. It's only been a month. And I really, not just because I volunteered to do a presentation, but I said, this was mind-blowing. I really wanted to learn more about this. So I started doing a lot of research, reading a lot of articles, and watching, seeing what other photographers did. And another phenomenon with the colors in the atmosphere, if you think, so in mid-latitudes or even further south, I'm not sure the folks in Texas or Florida could see the green. Because of the curvature of the Earth, they're far enough south where they could only see the red colors that were higher in the atmosphere. It's certainly possible, which is really interesting to me. Oh, man.
I was in eastern Idaho at the time, and I just walked out of my apartment and looked up at the sky, and all I could see was this just very faint reddish haze
Mhm.
over everything that night. And I didn't think to take pictures, but I probably would have seen maybe a little bit more. But yeah, that was all I noticed was that red haze. It's really cool
Mhm.
to know what that is.
Yeah.
I was just curious also, have you thought of using other types of cameras? Because these cameras are just standard red, green, blue
Mm-hmm.
sensors. They're multispectral thermal sensors, and other types.
Have I thought of using other cameras? Yeah, I'd love to have access to that stuff, but I think it's probably outside of my budget. One thing I wish I had done, and any of you could have tried this, is to put my smartphone on a camera, tripod, and just try to video with that, because it might have been, smartphones are amazing. I often see posts on social media where they proudly claim that the photograph had no edits. Well, actually, the people that designed those smartphone cameras, there's all kinds of processing of that image that happens before you see it. And but I should have taken I gave up on the big Sony video camera, but I should have tried a smartphone video. And if I had to do this again, when the solar storm of the century happens twice in 1 year, I'll try some time-lapse photography, because I have more than one camera. And so, yeah.
I brought out my standard 10-inch Smithsonian telescope out this night, and it was some of the worst stargazing I've ever had. The sky was way too bright.
Mm-hmm.
So depending on what instruments you bring out, you see different stuff.
Mm-hmm. So the human experience, that's DJ. Yeah, he was saying wow, but I made him stand very still for 30 seconds, kind of like the old Civil War era photographs. And I wasn't able to stand as still with my image. I did post one on Instagram, but you can see it's getting closer to midnight. Still doing my 30-second exposures. F-stop is coming down a little bit. And I started to, at first I moved my camera and tripods up near the fence line. We were just on a county road with barbed wire fences on both sides and some gates and stuff. And I because I didn't want to get, I wanted horizon in there, but I didn't want to get this kind of stuff. Fence posts and all that, destroying my photo. But then I realized, that might make an interesting foreground. And then let's get some people in there too. So DJ and I traded positions a couple times and did that. That was fun. But yeah, the human experience of this, of being out there, and you can't capture it with a still image. Seeing those patterns, seeing that light, constantly shifting and changing, it was incredible. And I'm not crossing Iceland off my bucket list. I still want to go there and experience that. And so
what direction is DJ facing?
he would have been facing east, and he was to the north of me in that previous photo. Yeah. Can you pick out any constellations, DJ? For orientation, I'm pretty sure I was looking north.
I know we were looking north. I recognize some, I can't quite use it to
Yeah.
I'm wondering if you had Cassiopeia preceding photo from this.
Mm-hmm.
Cassiopeia maybe the three square things.
Yeah, Cassiopeia would have been right there. I don't know how to get to the laser. That's Cassiopeia right there, Queen of the Skies. Good eye. So, this part also just blew my mind. We're looking south towards the Wallowas, and I never thought that I would be looking at the northern lights to the south of me.
And using them to light up the Wallowas.
And yeah, that was not moonlight that lit up the snow-capped peaks there. That was definitely the aurora. And so that was amazing. And they look a little brighter in the photos. I was having a hard time looking through the camera viewfinder to make sure they weren't cut off the bottom. I got a lot of bad photos of that. I also tried some of the Seven Devils, but to the east of us, and it wasn't successful with that. But this is right at midnight, and still using my 30 seconds. There's not much of a star trail, but anything longer than 30 seconds, you definitely start to see star movement. There's a little bit there. So I decided to go ahead and start including some of that interesting foreground business there. And an old wire gate. And there's Cassiopeia, easily recognized.
Okay, here's a question. What are the black lines?
Ah, good question. Anybody guess? Contrails. Contrails from airplanes. Yeah. And those darn airplanes ruined a lot of photos with a little flashing light going across the image, so I had to work really hard to time my photos in between those, but the evidence that they were there is still quite prevalent.
And note that they're all backlit, of course, because commercial airlines don't fly for the International Space Station.
Yep, everybody can see those, right? Those thin gray lines, especially lower in above the horizon. So, getting towards the end of our presentation, things calmed down a lot after 1 a.m. And so we had some nice green and yellowish. And if it was dark in here, you could probably see some pink and red in the photo too. But that depends on the human eyes as well. We definitely had a peak around a little after 11 p.m. And then we were starting to think about packing up and heading home. Because it was, and then it fired back up again. And I knew I was in trouble because, I just done photos and videos and stuff at the OK Theater before we went out to do the stargazing. And I also knew that I had to get up early and go make pancakes and eggs at the Hurricane Grange the next morning. And so after being out until I didn't get to bed till 3:30 that night, so that's I'm not used to be able to do that when I was DJ's age, but not anymore. So, kind of wrapping things up here, some lessons learned. Pay attention to the aurora forecasts and the weather forecast. You can all find the weather easy enough, but one of the best aurora forecast sites are the NOAA, National Oceanic Atmospheric Administration. Did I get it right? And the Space Weather Prediction Center. And they do a 30-minute forecast. And so you can always check that. And then there's more of a private site, auroraforecast.com. It's not a government agency, but that's what I mean there. And then after the fact, I started researching, what I did wrong with these photos. So I looked up, there's a lot of resources out there on how to photograph auroras. And these are folks that live in Northern Europe, Norway, Alaska, that kind of stuff. And but I do have a friend who I used to work with in Alaska when I was up there. And he was in Fairbanks during this incredible solar storm, but it's daylight 24/7, so he saw nothing. And right, so too bad, so sad. And when I worked in Alaska, it was mostly just during the summertime, and of course there was no opportunity to see aurora then either. And then a lot of this discussion I've shared with you about how the human eyes work compared to camera sensors was from an article that I have an excerpt here if anybody's interested, called by the Aurora Guy. And the gentleman is a PhD student and works out of Fairbanks, Alaska, and has been studying this for some years. So a lot of good information there. The other lessons learned, just experiment with your camera settings. Know where you're going. Originally, I had intended to go to Kinney Lake, because I thought it might be interesting to have some water in the foreground to the north of me, but I didn't realize the extent of, what the aurora would be, 270 on the horizon. And so, but think about other places you might go. A lot of people just walked out in the street in downtown Enterprise and could see it just fine, but bring a friend with chairs and snacks. I brought a chair and some snacks. DJ was sitting on my cooler. And in fact, at one point, he was laying on my cooler, looking straight up at the sky. And then just also don't mess, at least the aurora lasts a lot longer than, say, an eclipse that's only 4 minutes long. But be present and enjoy the amazing natural phenomena. Everybody experiences it differently, but being with friends, and so don't forget to, ignore the camera and enjoy the experience. So, any more questions? We're right at 1 o'clock, so I'm willing to stick around afterwards and talk about it if you'd like.
I'll also really plug the being present, because this was a 1 in 100, maybe 1 in 1,000 times, which means both of us have gone out a lot of times and not seen much. So all those other times, when I've gone out with a telescope and just said, okay, not much tonight, were those times worth it? Yes, and they were worth it not because, I'll get the great one someday. They're worth it because I was out there enjoying the natural beauty, often with friends and snacks. So you don't have to have an astonishing aurora prediction to get outside and have a good time under the stars.